Okay. Hello, everyone. So, our today's problem is minimize XOR. Okay. Now, what we are given here, we are given two positive integers num1 and num2, and we need to find a positive integer x such that x has the same number of set bits, which means like the x has same number of ones as num2, which means like if there are some number of ones given in num2, we only need to adjust it somewhere in the left or somewhere in the right or somewhere in the middle uh, to minimize the XOR of num1 and that new combination. Okay, so what this means is like let's say we have one example here. Okay, yeah. So let's say we have some example. I am going to take two or yeah this same example, three or five, three and five. So binary for three is 0, 0, 0. Oops, 0, 0, 1, 1, and for five it should be 0, 1, 0, 1. Okay, we need to adjust these ones such that the XOR should be minimum. So what is the XOR table for XOR truth table, right? So it is zero for equal and one for different. Okay. Now we only have control over the ones here, right? Because we are given a number with a bit a number. So this number indicates that we are given this many number of ones. Okay. So we need to manage only once here. And what is the better way to minimize a number? Uh, we need to provide a result which should result in zero, right? Like this one and this one should result in zero. And this one when put here, so this one and this one should result in zero, and the rest of bit will be zero. So the answer for this should be 0, 0, 1, 1, right? And even if we take a different example, 0, 0, 0, 1 and 1, 1, 0, 0. Okay, this is for 1 and this is for 12. Okay, now we need to adjust these ones here, right? So let's say we have a string with all zeros, and and if we want to adjust this one, where will we put it? We will put it here, right? Like one, because the one is here. We need to map this one, so the resultant answer will be zero. Now we have one remaining zero, one remaining, a single one we are remained with, right? Now, if we want to minimize a number, but we also want to insert it, how do we add it? We will need to add it from right to left. So whenever we find a zero from right to left, we will add it there. So let me add it here. Here. Now, why we are adding from right to left, left to right? Okay, so because we have 1, 2, 4, 8. This is first bit. This is bit with power 2, bit with power sorry, power 0, power 2, power 1, power 2, and power 3. Okay. Now, how will we add ones? Okay. Now, let me, yeah, okay. How will we add ones here? Okay. We will find the highest bit and try to set it to 0. Okay. Even if I had a 1 here, let's say, even if I had in num1 for num1, let's say, if I had this number and I had two ones, let's say this 1 and 1. Okay. So where would I want to put it? I would want to put it here, right? And the another one, like I have used this one, and the another remained one, I would need to put it so that the number is minimized. So I'll need to put it from left to right, right? So while canceling one, we will traverse from right to left, left to right, and while minimizing the number and managing the remaining ones, we will traverse from right to left. So let's get on with the code. Okay. Now, what I will need to do, I'll need to create a binary. So num1 of binary should be binary of num1. Okay. Now this gives me a result in 0b, and let's say the our number is 3. So it will give me a result in 0011. Okay. But we don't need this 0b part. So that's why we are going to trim it to 2 and here. So by this way we will get only this digits. Okay. One more thing here is like for 3 here we will get only 1 1. Because the binary function, this bin function, it removes the preceding zeros. Okay. We will manage it later, let's say. Okay, now we'll need a count of the binary of num1. Okay. So simply using the len function here, num1 bit, and we'll be doing same with num2. Okay, so I hope this part is clear. Now, let's yeah. So here we have a 5. Okay, so the binary for 5 is 0 1 0 1, right? And the binary and the actual output will be here 0b101. So what we'll need to do is we need to equalize this like 1 1 and 101. So what would be the best way? We'll need to add a 0 in front of this 1 1. Okay. So what we'll do is check the we'll check the balance, like what is the balance, what is the difference in this two len. So we will take the absolute difference between len of num1 and len of num2. Okay. Here num1, right? Okay. And we will adjust it if len of num1 is greater than no, then num2 bin is equals to 0 into balance. And we will again add it to num2 bin, right? And we'll do it same with num1. Okay. Now we'll create an empty list here, 0. So we will insert our ones in this list. Okay. And we can take the length of maximum length, whichever length we have. So again here, right? Uh, yeah. So hope this much part is clear. Now, what we need to do is we need to take the count of ones in num2 because we need to adjust these ones, right? So what I will do, I'll create a variable num2 set is equal to num2 bin dot count, and we need the count of 1 here, right? We will traverse from left to right. So for I in range and the then one num, right? Num1 of bin. Okay. So this is the length of binary of num1. We can take any because both the lengths are equal. So what we'll do is we'll check like if as we are traversing from left to right, uh, we need to cancel out the higher bit. Okay. So we'll check like if the num of bin of I is equal to 1 and our num2 set bits is greater than 0, then what we will do is we'll set the ls of I equal to 1. So the result will be 0. And we will decrease this num2 set, because we are using up the we are using up the remain our count of ones, right? And same thing we will do for right to left. So len of ls hyphen 1, okay, and yeah, -1 comma -1. Now why did I take here ls? Because like we already have a length of bits, and I need to start from right to left, and I have to manage. Let's say let's say here a count is 5 here, right? And I have used up or let's say nearly uh, three ones here. So I'll need to manage the remaining two here, right? So that's why I'm putting these ones. So the two ones from right to left, and simply we will return yeah, dot join ls, and we need to create it to integer. Okay, answer for this is the trouble. Okay, sorry. Let's check. Okay, so this bin is num1, num2. Okay, and yeah, okay. I think everything is right. Let me. Yep, I did compile it my own compiler, PyCharm. I don't think there is any issue here. Was there? Okay, okay. We need to set this one here, right? So, what we needed to do is like we need to check like if there are any zeros from right to left we encounter, and we set it to 1. And when we run it, yeah, it gets accepted. Thank you, everyone. That's it for today. Please like, share.